Configuring DNS and DHCP service. From this lecture, you will be able to understand NAT and port forwarding, understand policy-based routing, understand DNS service, understand DHCP service. Hello, today's topic is DNS and DHCP service. Much like the first session, only the essential configuration will be introduced in the video. Please refer to provided solution to find out about the uncovered topics. First, let's work on configuring NAT for the communication between the private network and public network. Configuring the server of fw.hrdkorea.kr will be shown in the video. IP tables might not be the handiest tool, since it cannot define service objects and it requires a lot of repetitive work. For this reason, NF tables, the improved version, is preferred nowadays. Well, I'm not so used to NF tables, so I will use IP tables. For outbound NAT, it goes through the router engine in kernel, so no NAT process is essential. Because there are 3 IP addresses whose internal hosts are NAT, let's create 3 new chains. Configure so that packets, whose final destination is the internal host, won't be NAT'd. For services within a private network inside the firewall, configure port forwarding so that it registers every time allocated services are configured. In this process, we will deal only with the DNS service. Save NAT policies. Every packet originated from the 172.16.0.24 network must be NAT'd in the firewall of hrdkorea.kr. So, policy-based routing must be established. Add a table hrdkorea in etc iproute2 rt tables directory. The mangle table is usually used for TOS, TTL, and MARC. We will mark every packet with 0 and 1 value, excluding the ones that headed from 172.16.2.0.24 to 172.16.1.0.24. These packets will be sent to hrdkorea.net site with the 10.0 interface past the routing table. Establish policies so that packets marked in the mangle table have a default gateway of 10.0. Once the configuration is complete and the interface is in up status, send ICMP packet from dc2.hrdkorea.kr to root DNS server. Capture the ICMP packet with the TCP-DUM program in the root.dns server. Send 5 ICMP packets from dc2.hrdkorea.kr. If the source IP address of the ICMP echo request packet is shown as 210.104.1.2, the configuration was successful. That was the end of the network layer configuration. Now, let's get to the configuration of the application layer service. Install DNS service for hrdkorea.kr domain in mail.hrdkorea.kr server. Make sure to configure the view of blind 9 because the service needs to respond with private IP in private networks query and with public IP in public networks query. Furthermore, it must be able to respond to the dynamic update request from the DHCP service and Active Directory service. Root.hint must be in every view while configuring blind 9's view. So, comment the line that includes root.hint in etc named conf. This part will be included in each view later. Some modern DNS servers provide DNS service according to the DNS SCC signature process. That is, to protect the server from a DNS cache poisoning attack, but in this demonstration, we will not use it. Let's permit recursive query only in hrdkorea.kr site. Zone setup could be done with an additional file, but I will configure it in the bundle file. If queried from the shown networks, record values in hrdkorea.kr.int, zonedb will be provided. Include root.hint value that is commented in etc named conf file. Make sure that dynamic update request from the Active Directory service and DHCP service will be responded to. Let's apply the revised zone setting only in the internal view. Configure external view for public network zone. Check if there are any grammar errors in the zone configuration. Duplicate and use the bundle zone database file for each zones. Change SOA record values in each zone database file to FQDN. For the contents in each zone database file, please refer to the attached solution. Once the configuration of the zone database file is complete, check if there's any grammar error. Restart the Blind9 service and create a resolver. Eliminate root.hint since this server serves as root DNS. Duplicate and use the bundle zone database for the zone database. Change the SOA record value to FQDN of DNS server. Configure delegation setup for hrdkorea.kr domain and gift.net domain. Pretending that the DNS service configuration for hrdkorea.kr domain and gifts.domain is complete, run query test. change root.hint value of hrdkorea.kr DNS server and gifts.net DNS server and restart the service, and run a DNS query test in domain client. Install DHCP service for hrdkorea.kr users in dc.hrdkorea.kr server. Configure so that dynamic update requests in the DNS server are met all the time. DHCP discover message cannot reach DHCP server, since client1.hrdkorea.kr host is a different network than the DHCP server. So install DHCP Replay service to fw.hrdkorea.kr so that DHCP discover messages to fw.hrdkorea.kr server would be delivered to dc1.hrdkorea.kr server. Renew IP address in client1.hrdkorea.kr host and check if the query to its host runs well. Define the interface to listen DHCP service. Comment IPv6. We don't plan to use this. Comment global setting, since each subnet provides different option value. Configure DNS dynamic update information. Configure each subnet options. testing client host.